The Bell XV-3 was an experimental aircraft that was designed and developed by Bell Helicopter Textron, Inc. The primary goal of the XV-3 program was to create an aircraft that could combine the vertical takeoff and landing capabilities of a helicopter with the speed and range of a fixed-wing aircraft. The XV-3 was one of the first experimental tiltrotor aircraft ever built. The aircraft was powered by Pratt & Whitney R985 Wasp Junior engines, generating 450 horsepower. The aircraft had a wingspan of 30 feet and a length of 31 feet and height of 13 feet. It was piloted by a single pilot and could carry up to 2 passengers or crew members. The XV-3 had 2 rotors mounted on the wings, which could be tilted vertically for takeoff and landing and then tilted horizontally for forward flight. The rotors were made of aluminum and had a diameter of 26 feet. The rotors were powered by drive shafts that ran from the engines to the rotor hubs. The XV-3 also had 2 small horizontal stabilizers mounted on the tail. The aircraft's unique design allowed it to take off and land like a helicopter, but then transition to forward flight like a fixed-wing aircraft. The aircraft could fly at high speeds and altitudes, and had a maximum speed of 167 miles per hour and a service ceiling of 15,000 feet. The XV-3 had a range of over 430 miles. The aircraft was primarily used for research and development purposes. The United States Army, Navy, and NASA all tested the XV-3 extensively in the 1950s and 1960s. The XV-3 was used to explore the potential of tiltrotor aircraft, and to investigate the various technical challenges associated with this type of aircraft. One of the key advantages of the XV-3's design was its ability to take off and land vertically. This made it ideal for military operations and search and rescue missions in areas where traditional aircraft could not operate. The XV-3's vertical takeoff and landing capabilities also made it an attractive option for civilian use, such as for emergency medical transport. Despite its potential, the XV-3 never entered production. The program was cancelled due to several technical challenges. One of the main challenges was the transition from vertical to horizontal flight. During the transition, the aircraft was in a state of instability, which required precise control to maintain stability. Any deviations from the proper flight path could lead to the aircraft losing control and crashing. However, the XV-3's legacy lives on in the tiltrotor aircraft that we see today. The Bell V-22 Osprey, a military transport aircraft, is one such example. The Osprey uses tiltrotor technology similar to that of the XV-3 and is capable of taking off and landing vertically, as well as flying at high speeds over long distances. The Osprey has been in service with the United States military since 2007 and has proven to be a highly capable and versatile aircraft. And that concludes our look at the Bell XV-3, an innovative aircraft that paved the way for modern tiltrotor technology. Thank you for watching.